Okay, imagine this. Imagine watching our entire solar system form, not, billions of years ago, but right now, like happening in real time.
It's a pretty mind-bending thought, isn't it?
It really is. And that's basically the extraordinary view astronomers just got. So today, we're doing a deep dive into this really unprecedented scientific discovery.
Yeah, the direct observation of rocky planets actually starting to form around a young star, a sun-like star, outside our own solar system.
Exactly. It's like looking at time zero for new worlds. So our mission here is to unpack the snapshot, figure out what astronomers actually saw,
Huh?
and try to understand what it tells us about how planets get started, maybe even our own Earth, right?
Yeah.
And what it means for other worlds out there.
And this is all coming from solid research, right? New stuff.
Yeah, exactly. It's reported in the journal Nature, and the Associated Press highlighted some key details, too. Okay, so let's unpack this. It feels like a peek behind the cosmic curtain. What makes this observation so, well, groundbreaking?
Well, what's really fascinating here is just how significant this is. I mean, scientists are calling it an unprecedented snapshot of time zero.
Like zero.
Yeah, that moment when new worlds begin to gel. It's really what astronomers have been waiting for. A really rich opportunity to see the process directly.
Right.
Melissa McClure, she led the research team from Leiden Observatory.
Uh-huh.
She put it really well. She said, "We've captured a direct glimpse of the hot region where rocky planets like Earth are born,
Wow.
around young protostars. For the first time, we can conclusively say that the first steps of planet formation are happening right now."
So it's not theory anymore, it's observation.
Exactly. Happening now. And, even researchers not involved are excited. Fred Ciesla at the University of Chicago said something like, "This is one of the things we've been waiting for."
Yeah, I saw that quote.
He mentioned, astronomers have been thinking about how planetary systems form for a long, long time.
So tell us about the star itself then, HOPS 315. What's special about it that gives us this view?
Right, HOPS 315.
Yeah.
You can think of it as like a baby sun.
Oh, yeah.
It's a yellow dwarf star in the making, a lot like our own sun, actually, but just incredibly young. We're talking maybe 100,000 to 200,000 years old.
That's nothing, cosmically speaking.
Barely an infant. And it's about 370 light years away, which, sounds far, but remember, light year is already 6 trillion miles, so.
Still mind-bogglingly far. Okay, so it's young, it's distant. How on earth did they manage to see into this system, to see something so, fundamental happening?
Well, it was a combination of things, really. Kind of a lucky break in some ways, plus amazing technology.
Okay.
So this star's gas disk, the cloud it's forming from, it had this gap, like a window almost, in the outer part. And that let them peer right into the inner region where the action is. A region that's usually, totally hidden by all the gas and dust.
So the gap was key.
Definitely. And also, the star itself, it's tilted just right towards Earth. We get this almost face-on view of the whole thing unfolding.
An observational jackpot, like you said?
Pretty much. And they used NASA's Webb Space Telescope.
Of course.
And also the European Southern Observatory, ESO, down in Chile.
Yeah.
Powerful tools.
Right.
Actually, ESO's Almay telescope network got this amazing visual. They described the system looking like a lightning bug glowing against the black void.
A cosmic lightning bug. I love that. It really helps picture it. So, okay, here's where it gets really interesting for me. What were the actual ingredients? What did they see condensing?
Or the building blocks. They detected solid specks condensing, specifically silicon monoxide gas and these crystalline silicate minerals.
Okay, silicates. Like rock, basically.
Exactly. And for astronomers, this is huge because these aren't just, random materials. These are the exact high-temperature things that our models predict should form first.
Just the very first solids.
The very first solids to condense out of that hot gas close to the star. It suggests that, the recipe for making rocky planets might be pretty universal, down to the first ingredient.
And where is this happening? Like, how close to the star?
Good question. It's unfolding in a spot that's comparable to our own asteroid belt.
Oh, interesting. Between Mars and Jupiter in our system.
Right. Which, as you know, is full of leftover bits from when our planets formed. So it fits the picture really well.
Okay, so what's the biggest aha moment here? Is it just seeing the stuff, or is there something deeper about how it's happening?
It's definitely deeper. I mean, seeing these specific hot minerals condensing like this, it had actually never been directly detected before around other young stars.
Never. Wow.
Yeah. So it raises this really important question. Was the way our solar system started, with these materials forming first, just some kind of, unique fluke?
Or is this how it usually goes?
Exactly. Is it a universal process?
Yeah.
And this study, well, it strongly suggests it could be a common process during the earliest stage of planet formation. That's a big deal.
So it makes our solar system seem less special, maybe? In its beginnings, at least.
In its beginnings, potentially yes. Before this, researchers had looked at, either really, really young gas disks or much older ones where planets were already partly formed. But this specific evidence, seeing the very start of the rocky material coming together, that's new. That's the breakthrough.
That really does change the game for understanding how planets like Earth get made. Okay, so looking ahead then, what's next for HOPS 315? Can we, watch planets actually form there over the next few decades?
Well, not quite on that timescale. Planet formation takes millions of years.
Yeah.
But it's impossible to know for sure how many planets will form, of course.
Right.
But the thinking is, if its gas disk was as massive as our suns might have been way back when,
Yeah.
then it could potentially end up with something like 8 planets, maybe a million or so years from now.
A potential sibling solar system in the making.
Could be. And the researchers are definitely eager to find more systems like this. Meryl Van Hoff, one of the co-authors from Purdue, she's really keen to basically cast a wider net now. Find more of these budding planetary systems.
To see if HOPS 315 is typical or unusual.
Exactly. Look for similarities. Try to figure out, what processes are really crucial for making Earth-like worlds versus other kinds of planets.
So stepping back from just this one star, what's the grand overarching question this research helps us get closer to answering?
Well, it really brings us back to that fundamental question, doesn't it?
Yeah.
Are Earth-like planets common out there? Or are we, so special, so unique that we shouldn't really expect to find many others like ours?
And this discovery suggests the starting conditions might be more common than we knew.
It definitely pushes the needle in that direction. It suggests the first crucial step for making rocky planets isn't some rare occurrence. It happens.
What an incredible deep dive this has been.
Okay.
Seriously. We've basically witnessed the genesis, the very beginning of a planetary system forming, seeing those first building blocks.
It's pretty amazing stuff.
And for you listening, this isn't just abstract science, right? It's a window into how our own world probably got started.
Yeah, our cosmic origin story.
And maybe how countless other worlds are starting out right now across the galaxy. It's a piece of that bigger story.
Absolutely.
So here's something to chew on. If these first steps, making the basic rocky stuff, really are common, what does that suggest about just how many Earth-like worlds could be out there? And then what other steps, what other unique conditions might be needed to go from just rock to a planet like ours, capable of supporting life? Something to maybe think about next time you look up at the night sky.